Okay, welcome to the overview section. Now we're going to look at how Meteor works in the round. So this is a little diagram we've got which shows a whole series of items, and you start off really with your machine analysis. So for geometry in particular, what we want to normally do is establish the primary axis for a machine and make sure that that axis, normally in this case a rail for example, you got to make sure that that is perfectly straight and perfectly aligned to your principal monuments normally in the floor, or your targets in the floor. So when we say perfectly aligned, you've got tolerances, so you got to go and check those out. Once you've got the rail itself, the foundation of the machine in correct working order, you then got to make sure that the movements along those planes are parallel. And third up, the alignments themselves are parallel or perpendicular to one of the primary axes. And finally, once these are correct, then you can work on positions. And this is important because very often when you go to do a dimension change or to change your sizes or whatever you're doing on your equipment to make a different product line, it's only the positions that move. However, if you start to move or adjust the wrong components, the alignments, or play around with the movement parameters, you're going to find it very difficult to get back to the good running condition that you had for the previous run of that product. So those are general predictions or general assumptions to be made when you're launching a study such as this. So analyze your machine with those four principles in order. Next up then, in our diagram, we look at to create a recipe. In this case I've called it a recipe, but it's content. You use the Meteor web page interface, which runs on a secure HTTPS site, which means the content is not available to anybody else. You use the web page interface, and through this you load up the images that we've seen in the demonstration. So those images are normally created using simple imaging software. Take photographs. It doesn't actually matter what you use as long as you convey the message succinctly in an image. This actually allows for content to be used in many different countries without the need to do so much translation work. If an image can get the message across, it's so much the better. You also use the recipe system to create and specify the tolerances for the product, to build the calculations in, and so on and so forth. So once you've built your recipe, you can test it, you can trial it, and so on. However, there's another option if you've got multiple sites where you've got so an operation in Europe, one in China, one in India, one in Thailand, one in Brazil, who knows where they are. But if you build your recipe in one site, the system allows you to duplicate that work, or to avoid duplication, by copying the recipe from one system over to another. And indeed there's a functionality where you can cascade results, a bit like if you get a software update. You get a notification to tell you that there's an update to the recipe that you've built. So you build the master recipe on one site, where your best technical resources are available, and you make that available to everybody else, and they get a notification on the remote site to tell them that they've got to go and download the latest version. So your servers are all networked, and they can update to and from each other, which allows you to develop a template that can be used once and be reused again and again. Quite a good feature, this, which wasn't in place when we launched, but some of our customers asked for it because they've got the same machines in multiple sites around the world. Works quite well. Next up then, you connect your measurement device. We've mentioned earlier you use PCDMIS, Spatial Analyzer Axis, to connect to the software, to the Meteor software. So those run in tandem with, we've trialed it with TDRA 6000s, TDA 5005s, Romer arms, various pieces of equipment, theodolites, tachometers, portable CMMs, but you can also use hand tools, and this is quite interesting. You can read measurements from a vernier and input the values manually into Meteor just as well. You don't have to use X, Y, Z, I, J, K for everything. You can just use X, you can just use Y, and so on. One-dimensional measurements are fine. The thing is that if you are using the hexagon equipment, it's pretty time-consuming, yes, to set up, but it's the accuracy serves a great purpose as well. Okay. So next up then, once you connect your measurement device and you've got it up and running, launch the Meteor client. Like we saw in the demonstration, you log into the client, and at that point in time the client will then connect over the network to the server. It'll establish a secure encrypted connection to the server, and then you log in. So using the encrypted channel, you authenticate to the server, and only at that stage, once the client has got the okay from the server to say that everything's okay, you can then choose which recipe you want to download. So if you're out in the field, you're at a particular machine, you don't need to browse through all the recipes. You just choose the recipe that has been built for the machine you're just about to measure. And the visual instructions will appear in a chronological order for which will make sense. If you've been trained to use it before, that's great. If not, this is a fantastic training tool for your next generation of users. So you launch the client on the same PC as the PCDMIS or Axis or Spatial Analyzer is running on. Okay, so finally get down to measurement. The illustrations here, we're using a CCR, a prism cube, which uses the TDRA 6000 uses, or you can easily use a manual device. The idea here is that you follow the visual instructions and read in the manual measurements, or the automated measurements get pulled into Meteor. Calculations, as we've seen, are performed in real time, and the results are compared with tolerances. So you've done your measurement, and next up you'll get your results. So once your results come in, you'll be able to see the indicators show whether the measurements are inside tolerance or not. You get initial visual feedback. So green, red, it's highly visible to anybody who's passing by, for example, and indeed the guy or the person who's performing the measurement. It allows the user to work towards a centered process. So you can get progressively better and better and better and more close to the value you're looking for. And indeed, the ability to chase the results that bring you inside tolerance are there. So what we've seen in the past is where somebody working out in the field may have settled for just good enough. Often they'll take that extra step or two to bring the results of your alignment well inside tolerance, which means next time round they're more likely to stay there for longer, producing better results for a longer period of time. And it encourages achievement, so you feel good that you've got the best result possible. Of course, after you perform the measurement for the first time, you may have to correct. So here we see the shim that gets used. So in this case, it's all structured out. The the person can reach for the correct size of shim, put it in place, and tighten everything back up again. And this is really where specific instructions can be embedded into the Meteor recipe. The content can really help the user in place to perform the corrections just as intended. But mechanical know-how really can't be replaced. So although you can document and although you can put all the instructions in whatever format you like, you still need someone who has been trained to a good standard to be able to make good on the corrections that you want them to apply. Okay, so once you've got your corrections and everything's okay, you're ready to store the results back to the database. And we've seen in the other demonstrations how that's done. The results are stored to the server, which is back in a central location. Again, final and initial values are shown. It could be that many iterations are performed, but none of those really matter in terms of the product that's produced. The products were produced at either the initial values or the final values. So once they're stored and the database has been confirmed that it's okay, you can then shut the client. The client application runs on the PC, so when it closes down, it actually deletes all of the images, all of the files, all of the calculations from its own system, which leaves the PC that you've got in a secure state. So we don't really want this to happen, but should the PC go missing, for example, you don't need to worry about the contents or the instructions or anything else. The data is really kept separate from the users out in the field. The next person who needs to use it will have to authenticate and download the recipe. The recipes aren't held on a local PC, which is vulnerable to failure. A server is unlikely to fail, and in fact backup copies keep this feature safe. Now that you've performed all the measurements, you're going to be able to analyze that those parameters you've measured are good enough compared with the standards or limits that you've set. And this allows you to determine whether the number of measurements is good enough, and you can always aim to have 100% of all your measurements carried out within a limited time frame and with results to within a good standard. You can assess completion on the key areas of your business, and most importantly, the success that you get at this stage will buy you time because your machines will perform better. You'll start to find strange things happen, such as a lot of the maintenance issues or the reliability issues that are associated with equipment start to come good, because in order to validate the geometry side of things, you have to actually, the machine has to be in good condition. So most of the maintenance people who you'll have working on this will be aware that their pride will kick in. Should they find anything that's out of line or badly worn, they'll replace it as they're going through the machine. And you'll start to find that most of the other reliability indicators start to come good. It's a complete mystery to those who are outside the process, but I've seen this again and again. Success will buy you time. The machine will run better. You'll get more time to perform the measurements next time round. And every time you go to validate it, it'll already be in a good condition because it was left in that state. So all the way back then to look at the characteristics. The product that you're producing is actually what you've got all the equipment for. And the goal for doing all of this work is to reduce product dispersion, because ultimately your customer will feel the dispersion. Not every product you make will be bad, certainly not, but there will be some outliers, and if you don't control the process, the characteristics will show up those feelings. Over time, as you apply the geometry and all the verifications outlined in Meteor, you'll start to see an improved product dispersion, better yield because you'll have fewer failures, and productivity that's going to go in the right direction. Just to give you an example, what we've seen in the past is that if the only thing that's limiting your production runs is your ability to put the people in place, you get a much better performing system. So where before you'd had some kind of unreliability based on the machine or the process, those kind of problems all disappear, and it becomes much easier to run your plant. You don't have scenarios where the people come to work and can't work because you're waiting for some intervention, for example. Lots of things like that start to come good, but ultimately you're analysing the characteristics of your product, and that's what the justification for all the work, that's where it all comes from. Okay, so just say you find that your characteristics aren't just where you want them to be. You then are going to have to focus your resources on the priority areas of your plant in order to make the corrections that you need, in order to achieve the verification plan. So you're making sure that everything stays good, and therefore avoid the reactive alerts, the costly breakdowns where all the resources that are necessary to get the equipment up and running to the correct standard are missing. So if you need to order in parts, if you need to do any particular work, you need to have all those things sitting ready, and that can be handled in a planned fashion much more effectively than in a reactive fashion. So in all, Meteor can start to help so many different areas, and hopefully this will have explained the overall process. Thank you very much, and remember to click on the links to register your interest, like and share, and hopefully we'll see you soon.